Somewhere off the coast of North Carolina, a river is moving. Not a river you can see. A river inside the ocean, thousands of times larger than the Amazon, carrying more water than every river on land combined. It has flowed in the same place for thousands of years. It is the reason London is warmer than Newfoundland, even though London sits farther north. It is the reason Europe is not buried under ice right now. And in the last few decades, it started to move out of place. Satellites watching the Gulf Stream near Cape Hatteras have caught it drifting northward. Slowly, quietly, year after year. And here is the part scientists can't stop thinking about. In their models, that exact drift is the first warning sign, the opening note of a collapse. So the question isn't science fiction anymore. The question is simple, and it's terrifying. What happens to the world if the Gulf Stream stops? Stay with me, because by the end of this, you'll understand why this single ocean current decides the fate of 2 continents, and why the first alarm has already gone off. And let me show you the stakes before we go one step further. If this current stopped, parts of Europe could become colder than Canada. London, a city that almost never sees real snow, could wake up to the Thames frozen solid, ice hanging from the wires, winters that belong in an ice age, not in some far future fantasy. In a scenario scientists are modeling right now. That is what's hanging on a current most people have never even heard of. So let's understand it, because it's bigger than the name suggests. The Gulf Stream is just the most famous part of a much larger machine, a planet-sized conveyor belt called the Atlantic Meridional Overturning Circulation. Scientists call it the AMOC. You can just call it the engine of Europe's climate. The way it runs is simple. Warm, salty water rides north from the tropics along the surface, dumping its heat into the air over Europe as it goes. That's the heat that keeps the continent mild. By the time it reaches the far north near Greenland, the water has cooled, grown heavy, and it sinks, plunging into the deep ocean and flowing back south to start again. Warm water north, cold water south, for thousands of years. That sinking is the heartbeat of the whole system. And here's why that matters to you. The amount of heat this current carries north is staggering. More energy than the entire output of human civilization, poured continuously into the air over Europe. It's why a palm tree can grow on the west coast of Ireland at the same latitude where, across the ocean in Canada, the ground freezes solid. Europe didn't earn its mild climate. It's borrowing it, every single day, from a current that starts in the Gulf of Mexico. So what could possibly switch off a machine that big? Something shockingly gentle. To sink, that water has to be heavy, cold, and salty. But the Greenland ice sheet is melting, pouring enormous volumes of fresh water into the North Atlantic. Fresh water is lighter than salt water. The ocean up north is getting warmer and less salty at the same time, and warmer. Fresher water doesn't want to sink. When the water stops sinking, the conveyor belt stops turning. That's the whole vulnerability. The most powerful climate system in the Northern Hemisphere can be jammed by something as quiet as melting ice, making the sea a little less salty. And the data already shows the engine losing power. The AMOC has not been this weak in over 1,600 years. There's even a century-old mystery tied to it, a strange patch of cold water in the North Atlantic, the one region of the ocean that has stubbornly refused to warm while the rest of the planet heats up. For decades, nobody could explain it. Now, the leading explanation is chilling in both senses. That cold blob is the fingerprint of a conveyor belt that's already slowing down. The weakening isn't a forecast. It's a measurement. Most people have never heard of the AMOC, even though it may be the most important machine on Earth. If you're already hooked on this kind of deep dive, Take a second and subscribe to How Our World Works. It genuinely helps. And what's coming next is the part that keeps scientists up at night. So if it's weakening, how would we even know before it's too late? That's the unsettling part. We might already know. And the warning sign isn't in some distant lab measurement. It's written across the surface of the Atlantic itself, in the path of the Gulf Stream. And you're about to see what it's been spelling out for the last 60 years. For most of recorded history, the Gulf Stream peeled away from the American coast near Cape Hatteras, North Carolina, and headed out across the Atlantic in a predictable path. You could set your maps by it. But satellite measurements stretching from 1993 to today show that detachment point creeping steadily northward. Subsurface temperature records going back to the 1960s confirm it. The Gulf Stream is not where it used to be. On its own, a shifting current sounds like a curiosity. Here's why scientists went pale. In high-resolution ocean simulations, models detailed enough to track the current kilometer by kilometer, researchers slowly added fresh water to the North Atlantic and watched what happened as the AMOC weakened toward collapse. And every time, the same thing happened first. Near Cape Hatteras, the Gulf Stream began drifting north. Gradually at first. Then, in a violent jump, it leapt 219 kilometers northward in just 2 years. That sudden lurch appeared a few decades before the full AMOC collapse in the model, a precursor, an early warning indicator flashing decades ahead of the main event. Now line that up with reality. The real Gulf Stream has shown a steady northward trend near Cape Hatteras for over 30 years, the same signature the models produce right before the system tips. We have moved past the era where AMOC collapse was a worry for the distant future. The first alarm is not theoretical. It's in the satellite record. It's already ringing. The only question left is how loud it gets, and what the world looks like if the engine finally stops. So let's do exactly that. Let's stop the engine. Not in 1,000 years. Tomorrow. Imagine you wake up and the Gulf Stream has quietly switched off in the night. What does the planet feel like in the weeks, the years, the decades that follow? The answer is stranger and more brutal than Europe gets cold. Because the first thing that happens defies everything you think you know about global warming. This is the cruel irony at the heart of the whole story. The planet is heating up. And yet, if the Gulf Stream stops delivering its tropical warmth, Europe doesn't warm. It plunges into deep cold. In some models, average winter temperatures across northern Europe drop by 5 to 10 degrees Celsius within a few decades. In the most extreme scenarios, winter cities reach lows that sound impossible for a modern European capital. Picture London waking to minus 19 degrees, the Thames frozen solid, ice hanging from the wires. Oslo trapped in deep freeze for half the year. Edinburgh plunged toward minus 30. This isn't a disaster movie. It's the output of climate models taking the warmth away and letting the latitude take over. Remember, London sits farther north than parts of Canada that freeze every winter. The only reason it doesn't is the ocean. Take the ocean's heat away, and geography collects its debt. And I'm genuinely curious. Would your city survive a winter like that? Drop where you're watching from in the comments. I want to see how many of you live somewhere that's quietly depending on this current right now. Then the ice comes south. In the moderate warming scenario, the models show Arctic sea ice spreading all the way down to the coast of Scotland and eastern England. Ice Age winters returning to a continent that, today, grows wine and olives. Growing seasons collapse. Late frosts and heavy snow delay planting. Crops built for mild winters simply fail. And here's the trap. A frozen Europe doesn't get a gentle climate in exchange. Because the rest of the world is still warming, the continent would still face increasingly deadly heat waves in summer, while enduring brutal cold in winter. The worst of both extremes, swinging back and forth, with agriculture and power grids caught in the middle. Meanwhile, across the Atlantic, the sea rises on America's doorstep. When the Gulf Stream slows, water that it normally pushes offshore begins to pile up against the eastern seaboard of the United States. A weaker AMOC is already linked to significantly increased flooding along the U.S. northeast coast. In a full collapse, sea levels along parts of the Atlantic could climb by tens of centimeters on top of global rise, drowning coastlines that today sit comfortably above the tide. Boston, New York, the whole northeastern shelf, paying the price for a current shutting down 1,000 miles away. And then comes the consequence that connects to a story you might already know. The damage doesn't stay in the North Atlantic. When the conveyor belt stops, the planet's tropical rain belts lurch southward, and one of the places that depends on those rains is the Amazon. Studies modeling an AMOC collapse found the Amazon rainforest could see its rainfall pattern flip, the dry season becoming the wet season, and the wet season becoming dry. The lungs of the planet, thrown out of rhythm by an ocean current on the other side of the world. The same tropical rain belts shifting south would also trigger severe droughts across the Sahel and disrupt the monsoons that billions of people in Africa, South America, and Asia rely on to grow their food. One current stops in the North Atlantic, and farmers in West Africa, India, and the Amazon basin lose the rain they've counted on for generations. This is the part people miss. The Gulf Stream isn't Europe's problem. It's a thread running through the entire planet's climate. And when you pull it, the whole fabric moves. From the price of bread in Lagos, to the floodline in Boston, to the snow on the streets of Paris. All of it tied back to whether one current keeps sinking off the coast of Greenland. So how do we know it can really happen? Because it already has. Roughly 12,900 years ago, at the end of the last ice age, a vast lake of glacial meltwater in North America, Lake Agassiz, burst and drained into the North Atlantic. A flood of fresh water, exactly the kind that jams the conveyor belt. And the AMOC shut down. What followed wasn't a bad winter. It was the 1300 years of cold, a period scientists call the Younger Dryas, an entire era of frozen, disrupted climate dropped onto the planet seemingly overnight in geological terms, triggered by a single pulse of fresh water hitting the ocean at the wrong place. Forests retreated. The newly warming world slammed back into the freezer and stayed there for longer than all of recorded human history. That's the proof. This isn't a hypothetical that lives only inside a computer. The engine has stalled before, and the planet paid for it in centuries. And here is what makes the modern version so unnerving. The trigger is the same. Last time it was one glacial lake bursting. This time, the fresh water isn't coming from a single flood. It's coming from Greenland, melting a little more every single year. A slow and steady drip that does the exact same thing. The Great Flood did, just quietly, over decades instead of days. And the Gulf Stream is already drifting north, right on cue, tracing the precursor pattern the models told us to fear. The last time this happened, there were no cities to freeze, no power grids to fail, no 8 billion people depending on stable harvests. This time, there are. If that just rearranged something in your head, you already know what the like button is for. If this is the first time someone has connected the dots for you, the melting ice, the drifting current, the frozen Europe, the flipped Amazon, then here's the one thing worth doing before we finish. Subscribe to How Our World Works and turn on notifications. This channel exists to take the biggest, strangest forces shaping our planet and make them make sense, and there is so much more of this story to tell. You won't want to miss what's coming. Now, let's bring this all the way home, because there's one final question that matters more than any model. Here's where the scientists are careful, and we should be too. A full collapse is not certain. Leading researchers stress that this is not settled science, that it's far from guaranteed the system shuts down this century. The honest range from the studies is wide. A possible collapse anywhere between the next few years and the year 2095, depending on how much we keep warming the planet. That uncertainty is not comfort. It's the opposite, because the same research that can't pin down the date is unanimous on the direction. The AMOC is weakening. It hasn't been this weak in 1,600 years. The fresh water keeps coming, and the one lever that controls all of it is the same lever that controls everything else: how fast we heat the planet. So come back to where we started. That river inside the ocean, off the coast of North Carolina, drifting quietly northward while almost no one watches. For thousands of years, it sat still and kept two continents alive. Now it's moving, in exactly the pattern the models warned us to look for. The Gulf Stream stopping tomorrow is still a what if. But the first alarm, the one the whole system sounds decades before it tips, isn't a what if anymore. It already went off. The only thing left to find out is whether anyone was listening in time.